In section 9.3a, we're going to start talking about tests about a population mean. So basically, we're going to be doing the same exact steps we did in the last section with proportion, except we have to use all the information what we know about means. So remember, confidence intervals and significance tests for a population proportion P are based on Z values from the standard normal distribution. Inference about a population mean mu uses a T distribution with n-1 degrees of freedom, except in the rare case when the population standard deviation is known. Remember, it's very difficult or very unlikely that you'll ever know the standard deviation of the population. We learned how to construct confidence intervals for a population mean in section 8.3. Now we're going to examine the details of testing a claim about an unknown parameter mu. So here we go. We're going to go through this example. It says, in an earlier example, a company claimed to have developed a new AAA battery that lasts longer than its regular AAA battery. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. An SRS of 15 new batteries lasted an average of 33.9 hours with a standard deviation of 9.8 hours. Do these data give convincing evidence that the new batteries last longer than average? To find out, we're going to perform a significance test where our null hypothesis, mu, is equal to 30 hours, and we think it's going to be greater than, longer than average, so our H sub A is we believe mu is greater than 30 hours. And remember, you should write down that mu is the true mean lifetime of the new deluxe AAA batteries. So to carry out a significance test, all of the same rules that we talked about in section 8.3 apply. The data has to come from a well-designed random sample or randomized experiment. It has to follow the 10% rule. When sampling without replacement, check that n is less than or equal to 1/10 of n, and the normal large sample. The population has a normal distribution, or the sample size is large, n is greater than or equal to 30. If the population distribution has unknown shape and n is less than 30, you can use a graph of the sample data to assess normality of the population. Do not use T procedures if the graph shows strong skewness or outliers. All the same rules that we talked about in the past. So just like in the last section, to perform a significance test, we do calculations assuming that the null hypothesis is true. The test statistic measures how far the sample result diverges from the parameter value specified by H sub 0 in standardized units. So we take our statistic, our sample mean, subtract it from our parameter, which is going to be mu from our null hypothesis, and we divide by the standard deviation of the statistic. For a test of the null hypothesis, mu is equal to mu sub 0, and our statistic is the sample mean. Its standard deviation is sigma of x bar of the sample means, which is the population standard deviation divided by the square root of n. But because we very rarely know the population standard deviation, we have to use S of x in its place. So that means we're using T distribution. Remember, this is where we have to do the degrees of freedom. So the battery company wants to test our hypothesis based on the simple random sample, and we were given that the x bar of the sample was 33.9 hours and the standard deviation of the sample was 9.8 hours. So using our information, we get a T value of 1.54. So we have the probability that T is greater than or equal to 1.54. We go to our table. Since we had 15 as our n, we go to 14 on degrees of freedom. Since the T statistic falls between the values 1.345 and 1.761, okay, so this time we have T. So this time we have the middle of the table. So we're looking here, our T is somewhere around here. So that tells us that our probability is somewhere between 0.1 and 0.05. So the p-value, we don't know it for sure. We have to estimate it if we use the table. So if we use Table B, we have to make sure of a few things. Table B gives a range of possible p-values for a significance. We can still draw a conclusion from the test in much the same way as if we had a single probability by comparing the range of possible p-values to our desired significance level. Table B includes probabilities only for t-distributions with degrees of freedom from 1 to 30, then it starts skipping and goes 40, 50, 60, and so on. The bottom row gives probabilities for degrees of freedom of infinity, which corresponds actually to the standard normal curve. If the degrees of freedom you need isn't in the table, then you need to use the next lower degrees of freedom that's available. And Table B shows probabilities only for positive values of t. To find a p-value for a negative value of t, we use the symmetry of t distributions. So when the conditions are met, we can test a claim about a population mean using one sample t-test. Find the p-value by calculating the probability of getting a t statistic this large or larger in the direction specified by the alternative hypothesis H sub A in a t-distribution with a degrees of freedom n-1. So it just shows you what the graphs should look like for the t-distribution depending on what your alternative hypothesis says. So for two-sided tests, the connection between two-sided tests and confidence intervals is even stronger for means than it was proportions. That's because both inference methods for means use the standard error of the sample mean in the calculations. So if you look, both of these, the test statistic and the confidence interval, use the standard error, the sample standard deviation divided by the square root of n. So a two-sided test at a significance level of alpha and a 100 times 1 minus alpha % confidence interval, a 95% confidence interval if alpha is 0.05, gives similar information about a population parameter. When the two-sided significance test at level alpha rejects the null hypothesis, the confidence interval for mu will not contain the hypothesized value. When the two-sided significance test at the level alpha fails to reject the null hypothesis, the confidence interval for mu will contain mu. We'll do this tomorrow.